This video is on absolute value functions. The absolute value function, f of x is equal to the absolute value of x, is another type of piecewise function. Here's how it's written as a piecewise function. F of x is equal to the opposite of x if x is less than 0, and f of x is equal to x if x is greater than or equal to 0. Let's take a look at that. So f of x equals the opposite of x. So that would be the same as saying y is equal to negative x, and that would be this piece of the line right here up to, and actually doesn't really matter where you put the 0 because it's actually a part of both of these lines, but up to 0. And then f of x is equal to x, or the line y is equal to x, our identity function right here, if x is greater than or equal to 0. So that would be that part of the line y equals x. Okay, and from what you're familiar with taking the absolute value of a number, so if x is negative 2, the absolute value of x is positive 2. If x is negative 1, the absolute value of negative 1 is 1, and so on. So you get this V-shaped function. It's an absolute value function, which is a good way to remember what it looks like. So as with a lot of other functions, the absolute value function can be transformed. It can be moved. It can be shifted up or down, left or right, flipped, and made wider or narrower. Its parent function is f of x equals a, which is going to be a constant, times the absolute value of x minus h plus, not within the absolute value, k, where the vertex, or that bottom of the V, is going to be the point hk. H and k are numbers. Now, if the value of a is negative, then the graph, your V, is going to be reflected over the x-axis. If a is a fraction between 0 and 1, then the graph is going to be vertically compressed. It's going to be closer to the x-axis. It's going to be squatter or wider. If a is greater than 1, then the graph is going to be vertically stretched, or kind of pulled up and closer to the y-axis, kind of a much more narrow V shape. If h is less than 0, if h is a negative number, then the graph is translated h units to the left. If h is positive, then it's going to be translated h units to the right. If k is negative, the graph is going to be translated k units down. And if k is positive, the graph is going to be translated k units up. So these letters, a, h, and k, describe how the basic parent function of the absolute value function is going to be translated. So let's take a look at an example here. So I need to graph this absolute value function. That's f of x equals negative 1/2 x times the absolute value of x minus 2 plus 3 by making a table of values that includes the vertex. Then I need to explain how this graph is a transformation of the parent function. So the first thing I'd like to do, that looks really messy. I mean, wouldn't it be a lot nicer if it were just y equals the absolute value of x? But instead I've got a number out front being multiplied, I have a number being subtracted from 8x, and then I have a number being added out here. So this value right here is going to be my a. A is negative 1/2. This value right here, h, is going to be 2. Now don't get tricked into thinking that h is going to be a negative 2, because h is whatever number is being subtracted from x. And k, my number out here, is going to be 3. That's just whatever is added or subtracted. That's what k is. So my vertex is going to be the point 2, 3. So I'm going to put that in the middle of my table because I want that to be kind of the bottom of my V. That's going to be that point right there. Okay? Although I'm noticing that my a is negative, so it's actually going to be flipped over. So let's go ahead and plug in a couple additional values here. Now normally I would probably put a 1 in here, but I'm noticing that I'm going to have to multiply. If I do 1 minus 2, take the absolute value of that, I'm going to have to multiply it by 1/2. In order to keep some nice y values, I'm going to choose x values that are multiples of 2. So I'm going to go with 0, negative 2, 4, and 6, because I know that when I subtract 2 and then I multiply by a negative 1/2, it's going to give me an integer value for y, which is nice. So when I put 0 in there, I have negative 2. Take the absolute value of that as 2 times negative 1/2 gives me negative 1 plus 3 gives me a positive 2. Plugging in negative 2, I'm going to get a value of 1. Plugging in 4, I get 2, and plugging in 6, I get 1. And you'll notice that it is symmetric about the vertex. So let's go ahead and graph that. So negative 2, 1, 0, 2, 2, 3, 4, 2, and 6, 1. There's one piece, and there's the other piece. Now, let's see, does that make sense? So my vertex was the point 2, 3, and indeed that is my vertex. Okay, and it's upside down, or it's flipped because of the negative, and it's wider because of the 1/2. So since A is less than 0, it's reflected over the x-axis. And since A is actually 1/2, let's see, let's say the absolute value of A is equal to 1/2, that means it's going to be wider. And since H is 2, it's been shifted from 0, 0, it's been shifted 2 to the right. And because K is 3, it's been shifted 3 up. So in this video, we took a look at another type of piecewise function, and that is the absolute value function, the shape of which is always going to be a V. We took a look at the parent function and how you can transform that by shifting it left, right, up, or down, making it wider or narrower, or reflecting it over the x-axis.